Welcome to SOLIDWORKS Live, where today we are diving deep into the cutting-edge world of simulation technology and its impact on, of course, design and engineering. So we're going to be joined today by experts Shreyas and Ronit, who are going to share their insights on how our innovative tools are revolutionizing the way design teams like yours create better products through the use of simulation. So we're going to see all this through the newfound vessel of our new for 2024 simulation value offers, which sensibly assimilate and price some of the best simulation technology for engineers and analysts on the market today. From understanding how simulation can predict fatigue failures and test nonlinear materials to exploring fluid dynamics and the power of cloud-based solutions, we are going to uncover it all. Plus, we're going to learn about the latest enhancements in simulation on 3D experience, the importance of Abacus solver technology, and get an exclusive preview of the new features inside SOLIDWORKS 2025 for simulation, a powerful, long-time favorite among designers and engineers using SOLIDWORKS everywhere. So first up today, we have Ronit Mukherjee joining us, who is a specialist in simulation and product development stemming from his time before working here at Dassault Systèmes. So Ronit is jumping on to explore the why of the newly announced simulation value offers and to discuss how simulation on the 3D Experience platform can accelerate product development, enhance collaboration among engineers and analysts, and to give us that sneak peek, the look at the exciting new features coming to SOLIDWORKS Simulation with the release of, you guessed it, SOLIDWORKS 2025. So let's now take a look at my conversation with Ronit. All right, everyone, we're here on SOLIDWORKS Live, and we're joined by Ronit. Ronit, what's going on, man?
Hey, man, lovely day over here. Can't complain. Living the dream.
Yeah, and you and I have been teaming for what, several years now, which it sounds crazy because I remember the first time you were on SOLIDWORKS Live, and I introduced you as my new teammate, just came from industry, my new sim colleague.
Thanks, man.
Yeah, but it's always...
Yeah, it's been a little while. I mean, it feels like it's been a lot of years. Like, you know, I feel like we've worked on so many live episodes and a lot of projects together. But surprised, you know, you won't believe it. It's only been less than 2 years. So
we have. It's true.
Yeah.
We have worked on a lot of projects together. I teased at the beginning of the episode. We're going to get to it at the end of this segment with what's new, some of your favorites from the simulation side, but and hopefully many more, man. But right now, we have you on to discuss the simulation value offers new in 2024. And this is really the kickoff of the episode here. And I wanted to ask you about the why, right? You know me, I always like to start off with the why. Why should anyone care? You know, so I wanted to ask you, what are these things that we call value offers, and why do we create them here at SOLIDWORKS?
Yeah, I mean, that's a great question, man. And it's kind of been the hot topic lately. You know, it's been a lot of talk behind it, what the value offers are and why we've created them. So, you know, just to easily kind of explain that to you, you know, the simulation capabilities on the 3D platform, there's quite a lot of stuff going on. We have a lot of different capabilities, a lot of different physics, a lot of different, like, let's say, prerequisites or standalone capabilities. There's a lot going on that can be a little bit confusing. So what we have done is we have collected, you know, some of the roles and kind of created them in packages. And we are offering these packages at a very discounted rate. So, you know, so it kind of takes away the hard work from, you know, our partners and our clients. Okay, what role do I want if I'm trying to solve this particular analysis? So that's one of the reasons. And the second reason, Sean, I would say is, you know, we want to give a simulation in the hands of everybody. So from designer to engineer to analyst to somebody who's running, you know, non-stop physics simulation. We want to be able to give that these simulation capabilities to everybody. And so we've created these value offers, and they're designed in a certain way where, you know, simulation can be used right from the start or in the middle analysis, like if an engineer is using, or again, like I mentioned, if an analyst who, you know, has a PhD whose job is just to run simulation analysis, you know. So we have packages that's been created and catered to all the different, people.
So when we talk about SOLIDWORKS, when we talk about simulation, right, essentially we're talking about our tools that help us with product development. And I mentioned read the lead in as we brought you in, right? That you came from industry, you know all about product development. So plainly speaking, how do these value offers help us accelerate the product development process?
That's a great question again. I mean, you're loaded with great questions, man.
Thanks.
So, simulation in general helps product development process. Users get a chance to solve complex simulations, virtually, and then, being able to evaluate different design options. And on the 3D Experience platform, we do it in a couple of different ways. Now, because everything is on the cloud, the data is on the cloud, your team is on the cloud. So all of this data is very easily accessible to anyone on the team or the stakeholders. The data is now with everybody. What can we do with this data? With the simulation, with the 3D platform capabilities, we can, of course, share this data, create markups, create images, create tasks. So you can create, let's say you're working on a project, Sean, and you have, X amount of engineers on it. Everyone has a different role. So you can kind of create this sort of a project management guide. And, these actually help in defining and, what someone's task is, when it's, when it's going to be due. So this whole process becomes important. It's not about just like running simulations and getting the simulation results. It's also about what can we do with that data. We want to be able to share it, get input from your teammates, and make necessary changes, and everything has to be organized. So it's a whole ecosystem.
Now we'll do a deep dive, as we've teased at the very beginning within the intro with our colleague Shreyas in just a moment on some of the different sort of neighborhoods of different types of problems, different domains of problems that we can solve within these simulation value offers. But one of the things I wanted to ask you as the producer of our first look, sort of our real introduction, our real video introduction of the value offers to the entire world, I wanted to ask you about solver technology, particularly within this area, within value offers of the Abacus solver technology. So it's something that I know we're very keen to discuss. And it's something I'm sure that our audience here watching on the SOLIDWORKS YouTube or LinkedIn has heard at length over the years, just us mentioning the Abacus solver. Why does this matter? Why does it matter that we're leveraging Abacus technology? Why should that matter to the end user today?
Great question again. So simulation. So let's start, to answer that question, let's talk about SOLIDWORKS simulation at first. So, SOLIDWORKS simulation is a great tool. It's been used around the world with tens of thousands of engineers on a daily basis, and it has been solving engineering problems for over, for decades now. But there are some limitations, Sean. So, let's say for example, working with some high-level physics simulations, there are some physics where SOLIDWORKS simulations cannot run those things. Now, what's happening in the industry? Are people not running these simulations? Are they not, analyzing products before they go into production? Of course they are. But they're understanding that SOLIDWORKS simulation is limited, so that might not be the tool. But now with Simulia, we have the capabilities of the Abacus engine. So with our 3D Experience platform simulation tools, the background is the Abacus engine that's running. And what that does is it brings to our existing SOLIDWORKS users and our existing simulation clients, it brings an extra layer of simulation capabilities that we can do. So, highly complex analysis like durability or explicit dynamics analysis, these require quite a lot of impressive engine to run in the back end to be able to give you correct results. And now we have those technologies. So whether you are an existing simulation user or you are not using simulation, we have the technologies that provides even a designer or an engineer or an analyst with a plethora of tools that they can use to run simulations.
And we know over the years, and surely since you worked on a lot of this content, and we've been hinting at giving some of this away during this episode here, that a lot of designers and engineers over the years have gotten, especially those using SOLIDWORKS, right? Because it's right within the task pane interface, right? It's accessible there as well as other areas in SOLIDWORKS. we know that a lot of designers and engineers have used SOLIDWORKS simulation products over the, the recent decades, right? So we know SOLIDWORKS 2025 is coming out fairly soon, just a couple months here, and we have a lot of content, several features that we have coming out in an upcoming video that you helped produce. But we said today, before that video comes out, we wanted to talk about some of your favorite features that you know of, that you've dug into, whether it's from core SOLIDWORKS simulation or plastics or whatever, what have you. So let me just ask you plainly, you run it, you've dug into SOLIDWORKS 2025 a bit. What are some of your favorite features that you've seen?
Oh man, too many to pick from. Usually we want to keep that suspense going till the last day. Hey, you have to wait it, but since you're my friend, I'll share it. So of course the goal is always to improve our existing tools and incorporate new technologies as we are improving the tools over the years. So this year there were a couple of enhancements that were done. A couple were done in the user interface mode, and a couple were done in the background. And I do have a couple of favorites actually. So the first one, Sean, I would pick is the general spring. So this is a new type of spring that has been introduced, and this allows a user to define orthotropic properties of a spring. So stiffness in all orthogonal directions, and as well as stiffness and bending points, we can define those now in the general spring. Before that, we were not able to define these things. And again, where the general spring sort of kind of enhances the quality of the results is anytime you're working with the spring, yes, it's going to be stiff in all different directions, right? So to get more accurate results, to get more accuracy from your setup, you want to be as close to what the real world scenario is happening. So the general spring brings that, extra layer of closeness to the setup, like a real world spring simulation. So that'll be my number one. And, actually the pin connector, they also have had a little bit of, an upgrade. So pin connectors have always been there, but now what we are using is, whenever you use a distributed pin connector, Sean, that technology is being brought over from Abacus. The decoupe technology that's being brought over from Abacus to our SOLIDWORKS simulation. So we are actually getting some stuff from Abacus as well. So we're trying to improve, what the existing SOLIDWORKS desktop simulation tools are, and we can do that by, borrowing stuff from the mighty Abacus. So I would say those two, man. To be honest, yeah.
I would say probably the second favorite part of my job, as far as what's new season goes, is seeing the new features as they're produced. We all sort of have our different subject area disciplines. Some of us are working on parts, some of us are working on assemblies, some of us are working on model-based definition, simulation. So it goes all across the gamut of what you guys use for customers. My favorite though is when we actually announce these within the What's New episode of SOLIDWORKS Live, because we get to see real time. It's one of the most gratifying moments. What you guys sort of think about within the live chat, what you guys think about the new features that we're unveiling for the first time. So yeah, I'm definitely looking forward to that. And for sure, this is like the easiest plug I've ever made. Please subscribe to the channel, because the easiest way to be reminded for next month when we have that episode and we unleash upon the world a lot of these features, including many simulation features. But yeah, man, thank you so much for coming on, Ronnie. Thank you for clarifying what these value offers are all about, why we have them for our customers, and we will see you soon, I'm sure.
Absolutely, man. It's a pleasure. And yeah, stay tuned. We can't wait to reveal all the good stuff to you. So join us soon.
And now, joining us next is Shreyas Vaidya, one of our simulation experts here at Dassault Systèmes. So Shreyas is going to provide us technical insights on how the cutting-edge simulation tools included in these simulation value offers, which once again are new in 2024, how they're providing and empowering design teams to create better products and explore advanced capabilities, such as fatigue prediction, nonlinear material behavior, fluid dynamics, and much more. So let's take a look. All right, everyone, we're here on SOLIDWORKS Live, and we are joined by Shreyas, one of our simulation technical experts. Shreyas, how's it going, man?
Hey, Sean, thanks for having me.
Absolutely. I mean, you've been on SOLIDWORKS Live a number of times, of course, during many of our most successful, I should say, simulation episodes. And you're here today, and you're also going to be here, I believe, for an episode of SOLIDWORKS Live Design, or other live streaming series where we do live demo and explore interesting projects. You're going to be doing like an airless ball of some kind, right?
That is right. So I will be on SolidWorks Live, I believe, in a couple weeks. So I'm going to be with my co-presenter, Noah, who you may have seen a few months back, showing off some 3D printed basketball designing skills. So that was something really, really cool, I thought. And what I wanted to do is, right after the presentation, I reached out to Noah and I was like, "Man, let's do something that is more like a football." Or, we were a bit confused about, okay, do you want to do a tennis ball? What Noah said was, okay, let's just ask the audience. And the audience, I guess, said was, okay, we want to see a football in action. We want to see an airless football in action. We've seen the basketball. We've seen the airless basketball. Let's show some football, which probably doesn't have any air, which is 3D printed. So Noah's going to design that in one of our X apps, and what I'm going to do is try and simulate it in multiple different ways, really. So if you have air flowing around it, if somebody throws the ball at a certain velocity, how does what's the drag on it? What is it aerodynamic enough, especially as how does it compare in terms of its aerodynamics with a traditional football which has air filled in it? So we're going to talk about that. Probably even do some drop test, see if our 3D printed ball stays intact on a drop, or does it get broken into pieces. So we'll find out a few different things on that episode.
Today, right, we have different ground to cover here, and not to say that it is more serious ground, but I would say maybe more industry-based. We're talking about the simulation value offers, right, that we have introduced here in 2024. We heard a bit about them from Ronit, our colleague, here in the intro, but I wanted to ask you plainly, just for some more, again, industry insight. How are the simulation tools that we're providing within these various simulation value offers helping design teams, like many of the the viewers have here on SolidWorks Live? How are they helping design teams around the world achieve what they want, which is, well, better designs?
Yeah, so actually, in many different ways, I would say the simulation tools we offer today to our customers, they put it in use, and they're benefiting from these tools in many different ways. So let me try and break down a few of these different ways that our tools are being used. So obviously, the first one comes to my mind is making decisions early in the product development phase, right? So if you're a designer, if you're an engineer, these tools, these simulation tools we offer can help you analyze and help you simulate your designs and its performance in real world, and how they would perform, right, when they undergo different loading conditions. If there are potential issues in the design, right? From a stress concentration point of view, from a thermal loading point of view, from excessive deformation point of view. So designers and engineers can identify these potential issues super early in the design process and make necessary changes to their designs so that they are not going to fail in field, right? They're not going to encounter any issues in the field. So that's definitely the first one that comes to mind, early design validation. In addition to this, the way these tools are being used are from an optimization point, right? Our designers, our engineers, they basically, they want to understand what is the best possible material I can use for so-and-so application. If my geometric configuration is right, right? Are my parameters right? So studies like these can help them understand which is the best performing design configuration of all. The third thing that again comes to my mind is once you're virtually building and simulating your designs, that helps you in reducing the number of prototypes you build, right? So for example, you can build hundreds and hundreds of prototypes virtually, test them, design them, iterate them, and then finally, once you settle on a best performing design configuration, go ahead and build the prototype to, actually understand its real world performance, which obviously are going to be very close to the best virtual case you build. So it helps you to reduce the number of prototypes you build, but then also speeds up that process because now you're studying hundreds and thousands of prototypes virtually, which also means that you're innovating faster. So that's again one of the important highlights of using simulation tool, and some of our users are already experiencing these gains in terms of time to market, faster time to markets, and being able to innovate their products faster and better.
So let's talk about a couple of those cases, right? And this technology, right, it's something that can be used by designers, engineers, analysts, of course. But let's talk about something that's pretty common. We saw it last year in the What's New cycle with Bowhead Corporation. A lot of their parts are subject to this particular type of failure, potentially, right? Something you want to guard against. Fatigue failures, right? A lot of the components within the structures of our various parts, various assemblies, various products, right, that SOLIDWORKS customers create may be subject to fatigue failures. So can you tell us a little bit about how the technology that's included within the simulation value offers in some tiers are able to predict fatigue failures ahead of time?
Yeah, sure. So let's address which value offer will help you predict fatigue failures of your structural systems first. So that would be the simulation analyst value offer, right? So simulation analyst value offer has the durability and mechanics engineer role, which in turn offers all the capabilities, all the tools to our users to simulate fatigue failures of their products, right? So this role actually uses the FE Safe solver or the FE Safe program, which is again tightly integrated into this value offer. So FE Safe is basically an end-to-end solution for all your low and high cycle fatigue applications. It is based. The fatigue simulations are basically based off of your finite element models and integrated in the same workflow. So one of the key highlights for this role or for this value offer, the simulation analyst value offer, is its capability to predict fatigue behavior of welds. So whenever you have a lot of welds in your structure, whenever you have a structure which is welded together, you can choose to identify, or you can choose to set up fatigue simulation using these capabilities offered by FE Safe to identify some critical points of failure on your structures. More often than not, these are in a welded structure. These might be the welds, some of the welds in your structure. So one of the key USPs of the simulation analyst value offer is its ability to simulate to understand fatigue failure of welds.
You bring a great point, right? When we talk about simulation, we talk about doing finite element analysis. The types of products that we're wishing to run analysis on is definitely something that plays a key role, of course, in the types of simulations and the types of considerations when we're putting together our various analyses. One thing, of course, that comes up quite often is the types of materials, right, that we're simulating against and their properties. So my next question is regarding materials. A lot of us may be used to SOLIDWORKS simulation here on desktop. We talk a lot about, linear static studies, linear materials. Let's talk about nonlinear materials in this case with the technology in the simulation value offers. Are we able to test the behavior of nonlinear materials, and what does that look like here?
Yes. So all the value offers we have, except the simulation design value offer, will have capabilities to account for material nonlinearity. What does this mean? Well, users can model nonlinear material properties and use them in their simulation. So users can, for example, let's say model plasticity into, or take into account plasticity of a certain material, which then they can use in their simulations. So just to kind of give you a quick example, some of the highly nonlinear materials like foam or rubber can be modeled using these value offers, and then be also used in simulations downstream.
Moving on to a different type of study type, a lot of our customers, whether it's air or fluids, they are definitely testing for these different types of dynamics. So let's talk firstly about fluids. Do any of these value offers contain fluid dynamics tech, and how are they best used by a designer or an engineer or an analyst?
Yeah, so our flagship value offer, which is the simulation multiphysics value offer, comes with the fluid dynamics engineer role, which is an end-to-end comprehensive solution for steady state and transient computational fluid dynamics simulation. So this role uses the Navier-Stokes-based flow solver that we have developed here at Dassault Systems, and has 3 different turbulence models to choose from based on the type of application you're solving, type of flow application you're solving. It's more or less used in a similar way our structural roles are being used by our customers. So, for example, early design validation is something comes very often, right? How do you iterate your designs? How do you try and identify those failures in your design from a flow point of view this time around, to then incorporate those design changes early in your product development workflow, right? You don't want to go into the prototyping phase and then find out, or you don't want the product to be launched and then find out some of these issues that you may have found out earlier just by using simulation. So that's one of the key advantages, which is trying and identifying these potential issues downstream when your products are in the market in the hands of your customers.
A lot of these solutions, we know our simulation value offers, like Radha mentioned, right? They many of them take advantage of Abacus solvers. Whenever we think about 3D experience, we think about this term cloud. But I want to specify with you, Shreyas, when it comes to that term cloud, what does cloud mean in the context of the simulation capabilities within these value offers? Does it mean, for example, I'm trying to put myself in the sort of, mind frame of our viewers. Does it mean, all the solving of these studies happens on the cloud, or does it mean, hey, you can solve using cloud computing resources? Could you clarify that a bit for us?
Yeah, that's a great question, Sean. So it could mean a few different things. Being able to just use cloud, or being able to solve on cloud, as you asked, right? So let me start with the very first one. So it definitely means you have the ability, or the users have the ability, to save their data securely on a cloud, right? Which also means that then you can access this data anywhere from any device. So the other thing, when you ask about cloud, is the ability to leverage high performance computing on cloud. So often these value offers we have come with some very advanced capabilities, which also means that users can run really large and complex simulations. And for them to be able to run those large and complex simulation, more often than not, the local compute might not be enough. So in these scenarios, in these cases, high performance computing on cloud, can be accessed or can be leveraged on. So basically, cloud can also mean that, okay, users have the ability to solve or run these advanced, large, complex simulation using HPC. And then the third thing it could also mean is, or cloud could also mean is, the ability to use cloud compute in pre-processing and post-processing part of your workflow.
Yeah.
So pre-processing would be, okay, I want to measure really, really large model. I want to measure really complex assembly. My local compute is probably not, high enough, or probably not capable enough to handle such, complex meshing of such complex assemblies. So in that case, what I can also do is then leverage, again, HPC on the cloud, high performance computing on the cloud, to discretize my model or mesh my model. It could also mean I can also use these high performance computing cores on cloud to post process my results. So basically, if I have I have a flow analysis case, I've set up a virtual wind tunnel to analyze an external flow over a car moving at a certain velocity. I'm generating a lot of data which may or may not be handled by my local compute. So I can, in this case, choose to use cloud compute cores to basically speed up my post processing part of the workflow.
You mentioned, of course, just now, right? There are so many elements to think about in terms of leveraging cloud resources, whether it's for storage, universal, as much as you'd like it to be universal, accessibility of your files, pre and post processing of studies or parts of studies. And I think one thing I'm also excited by is also just the accessibility of results. I think that's pretty awesome, right? So before, right, you could export, for example, to a Word document or Excel document, different artifacts regarding, say, reports from your findings from different, say, FEA or CFD studies, but the ability to actually attach, say, results to a task or tag someone when results are visible and they're visible on a phone or any computer, right? They just kind of follow a login in terms of who has access. It seems much more sensible. And yeah, I really like the capability. You're kind of mirroring the way that people like to work, but not necessarily attaching yourself to any specific machine, which sounds very 2024 to me.
Yeah. No, that's a very good point you bring up, Sean. Being able to have your data on the cloud also means that it can be shared faster, it can be collaborated on faster, and then as I said, everything just become faster from point A to point B, and everyone is in the loop too, right? We're basically not wasting a lot of hours just communicating, sharing files, uploading, downloading them. Everyone has access, everyone can have access, and everyone can collaborate better and faster.
Awesome. Well, Shreyas, I always learn something whenever we have you here on SOLIDWORKS Live. We'll look out for you on SOLIDWORKS Live Design with Noah. Another airless ball, this time probably one that people haven't seen before. So once again, thank you so much for jumping on, and we'll see you soon.
Thanks, Sean. Thanks for having me.
Thank you so much for tuning in to today's episode. We hope that you have enjoyed exploring the incredible capabilities of our simulation tools and learning about how they're helping design teams innovate faster and smarter. Now, if you're excited about what you heard and you want to dive deeper into our simulation value offers, head on over to 3dexperienceworks.com. So there, you're going to discover how our solutions can transform your product development processes, enhance collaboration, and give you that competitive edge. And we're not done yet this year. Next month, you got a tease of it today. You're going to get a lot more very soon when on September 26th, we are going to host our annual What's New in SOLIDWORKS live stream for SOLIDWORKS 2025. So I can say firsthand, my team and I, we have been hard at work with our feature customer, Proteus Motion, to show you some amazing new capabilities coming to your PCs very soon. Until next time, take care.